f of x is equal to a naught by 2 plus summation n from 1 to infinity a n cos 2n pi x by t plus bn, sorry, summation n from 1 to infinity bn sin 2n pi x by t. So this is a a naught is defined as 2 by t integration from c to c plus t f of x into dx an is 2 by t integration from c to c plus t f of x into cos 2n pi x by t into dx, and bn is again 2 by t integration from c to c plus t f of x into sin 2n pi x by t into dx. Okay, so this is a Fourier series. We have given this formula, and we have discussed again that also. So if the function the f of x is even, if f of x is even, then the Fourier series contains contains only cosine terms. It contains only cosine terms. That is bn is 0. So it not contains sine terms. So that is a one. And second one is if the function f of x is odd, then the Fourier series contains only sine terms. So that is a naught and an both are 0. Okay, so this is also another results. It will help to reduce our calculations. So the thing is, if the given function is even, if the given function is even, then in the Fourier series we have to find a naught and an. So here what is a naught and what is an? Only two terms we need to evaluate. Suppose if the function is odd, then we need to find just only one term, that is bn. So what is bn? That if you are to find, so I can directly write, since the function is odd, so I can directly write a naught and an are zeros. If this function is even, I can directly specify that bn is 0. So forget about the derivations. We will not going to derive how it is. Okay. So this is also result we have discussed, and now I'll take one example from the Fourier series. So I'll explain how to find the Fourier series, and this if it is not an even and not an odd. So I'll take f of x equals x by 2 in the interval 0 to 2 pi. Okay. So I hope you can view this screen. So find Fourier series, Fourier series, Fourier series expansion of the function f of x equals x by 2 in the interval 0 less than x less than is that 2. I just check that is that it is 2 pi, not 2. 2 pi, and f of x plus 2 pi is equal to f of x. So this is the condition they are given, and this is the function, a linear function, and the interval, this is the interval. So we need to find a Fourier series expansion. So if you see this function in this interval, so f of x in this interval, I cannot check it is even or odd. So the thing is, if I am, since I don't have a nature of the function in the negative interval, okay, so this is a positive interval. If I want to replace, what I have to do, I should replace x with minus x, and I have to verify whether it is a positive x or negative x to say it is even or odd. And since it is a periodic function, and if you draw the graph of the periodic function, obviously, so 0 to 2 pi, and this is 2 pi, sorry, pi, again this is, if I take minus 2 pi. So the graph of this function f of x in this interval 0 to 2 pi is a straight line. It is a straight line, okay, with the maximum value pi. And since it is a periodic function, so the nature of this has to replicate in other 2 pi period. So this is 0. So 0 to 2 pi is this. If I say the periodic function and I want to extend another cycle again from minus 2 pi to 0, so this is what the graph of the function. It will be, the same thing will be replicated. At minus 2 pi it is 0, and 0 it is pi. So the nature of this graph, since it is a periodic function, please remember we cannot say it is a even or odd unless it is defined in the negative interval. Okay, so this is right now the interval is not defined a negative part, and it is only a positive, I mean x greater than 0 it is defined. So the even and odd cases I cannot verify. So don't worry about, I mean it is not possible at all. I can extend in even or odd, that is different part of the Fourier series analysis. But right now, as a given function, we cannot say it is a even or odd. So don't do this calculation for a periodic function, please remember. So this calculation will give you continuous function as well as periodic function also it will give you, unless it is specified in the negative interval. Okay, so that's all. Now, so solution. So this solution, we have the Fourier series. So that, what is that Fourier series we have? F of x equals a naught by 2 plus summation n from 1 to infinity a n cos 2n pi x by t plus summation n from 1 to infinity bn sin 2n pi x by t is called as equation 1, and here where a naught is defined as 2 by t integration from c to c plus t f of x into dx, and an is 2 by t integration from c to c plus t f of x into dx. Sorry, so what is that actually? It is not dx. So we have one more term, that is cos 2n pi x by t into dx. And similarly bn is 2 by t integration from c to c plus t f of x into sine 2n pi x by t into dx. So this is the coefficients, and now we have a given terms. So given function is x by 2, so that we have to note x by 2 is given, and the interval. So here f of x is x by 2, and limits of, so c value, that is starting value is 0 and period is 2 pi. So these three are given, so it is enough. We can compute what is a naught. So to compute a naught, I must need a t, I must need f of x, and then the value of c. So all the three we have, so I can easily find a naught, an and bn. So this, now we have to note these three. So next, with this I can compute a naught. First we'll go by a naught. So a naught is 2 by 2 pi. So the period is 2 pi. Integration c is 0 to 0 plus 2 pi is 2 pi, and f of x is x by 2 into dx. So simple integration, 2 divided by 2 pi get cancelled. So this 2 cancelled, and we get 1 by pi. Okay, so that is 1 by pi into 1 by, so this 2 is also constant, I can take it outside that integration, so that becomes 1 by 2 pi, and integration of x, so integration of x is x square by 2, limits from 0 to 2 pi. Okay, now again this 2 also I can take outside. So this becomes 1 divided by 4 pi into limits. When you apply the limits, upper limit whole square minus lower limit is 0 square. So that simplifies 4 pi square, 2 square is 4, pi square divided by 4 pi, and 1 pi cancel, 4 get cancelled, 4 divided by 4 is 1. So we get a naught value is pi. So this is a naught value. So next part is I need to find an. So where an is 2 by t, so 2 by 2 pi integration from 0 to 2 pi, again c to c plus t, f of x is given as x by 2, and cos 2n pi x divided by 2 pi into dx. Okay, so again a simple calculation, simple simplification, 2 to cancel, this 2 I can take it outside, so that becomes 1 by 2 pi into integration from 0 to 2 pi x into cos 2 pi again cancelled, 2 pi cos nx into dx. So this is simple first function, Leibniz rule I can apply, first function into second function by parts rule. So that is an equals 1 by 2 pi into first function into integration of second function, that is cos nx into dx, then minus derivative of first function into integration of second function, that is cos nx into dx and limits from 0 to 2 pi. Okay, so with this again I need to simplify 1 by 2 pi. I am explaining this problem in detail, please don't consider okay. So x into integration of cos nx is simply sin nx divided by n minus derivative of x with respect to x is 1 into integration of, so again integration of cos nx, just now we got it as sin nx by n into dx. So limits from 0 to 2 pi. Again further integrate, so 1 by 2 pi into x into sin nx divided by n, so minus, what is integration of sine? So minus 1 by n, you can take it constant outside, integration of sine, so this n we can take it here, is minus cos nx divided by n, limits from 0 to 2 pi. So now apply the limit here, apply this limit now. So to before up, so what do we get when you apply the limit 1 by 2 pi into upper limit x 2 pi up into sin 2 pi n divided by n minus lower limit, so I am taking, so x 0 into sin 0 into sin of 0. Okay, so next is, here is negative sign, minus into minus, so this is negative sign, minus into minus plus 1 by n into n square, so 1 by n square, again upper limit is cos 2n pi and then minus lower limit is cos 0. Okay, so simple way I am explaining to understand the first problem. So now, so I think you have remembered the simple basic result, that sin 2n pi and is 0, that is nothing but sin n pi is also 0, where n is a integers. Okay, next this will be 0 and sin 0, obviously you know it is 0. So what is cos 2n pi value? The cos 2n pi value is 1, whereas cos n pi value is minus 1 power n. N is any integer, minus 1 power n. So this value is 1 and cos 0 value is also 1. So 1 minus 1, the whole term is 0, because 1 minus 1 equal to 0. If this is 0, these two terms 0, the entire term, if you simplify, you will get a 0. So what I can say, an is all zeros. All ans are zeros. I hope you got this calculation. So next I need to compute Bn. So Bn is again 2 by 2 pi, integration from 0 to 2 pi, f of x is x by 2 sin 2n pi x by 2 pi into dx. So you can cancel this 2 and we can consider this outside, you can take outside 2 and again 2 pi in the sign is also cancelled. You get 1 by 2 pi into integration from 0 to 2 pi x into sin nx. So again here is also we have first function, second function. So now I won't use the detailed way of by parts rule. So as we remember that if you have a u1v, so integration of uv is equal to u into v1 plus minus, second term is always minus v u prime, so you have minus u prime into v2 then plus u double prime into v3 and so on, plus or minus and so on. So that means the suffix v1 v2 v3 indicates integration, prime notation indicates derivatives. So that becomes, with this bn equals 1 by 2 pi into, so u, that is x, into integration of sine is minus cos nx, integration of sine is minus cos nx divided by n, minus, that is this formula, minus derivative of x is 1 into integration of this one. Already we have this function, you have to integrate this whole again, so that is minus, as it is minus cos integration is sin nx divided by n, and 1 by n is already there, that becomes n square. In again plus, what is the derivative of 1? Derivative of 1 is 0, that is derivative of constant is 0. So till this process continues till you get a derivative of the constant is 0. So that limits from 0 to 2 pi. So okay, so now substitute the limit and we can easily simplify. So 1 by 2 pi into, so negative x, so minus is there, x into cos nx divided by n, and minus into minus plus, we have sin nx divided by n square, and limits from 0 to 2 pi. So that gives you 1 by 2 pi, apply the upper limit, so we have negative times 2 pi into cos 0 minus 0 into cos 0 whole divided by n plus 1 by n square into sin 2 pi n or 2n pi minus sin 0. So upper limit minus lower limit. So as we know, as I said earlier in the problem, so earlier in finding cos, so this is cos 0 is 1 into 0, and sin 0 is 0, and sin 2n pi is also 0. So this is we have typing mistake. So here it is not cos 0. What is this? 2n pi. Cos 2n pi value is 1. So as we see, the cos 2n pi value is 1. So that becomes, simplify, we get bn equals 1 by 2 pi with negative 2 pi, and then this is 0 into anything is 0 divided by n. Okay, and finally we get minus 1 by n is the bn. The value of bn is minus 1 by n, where n is always greater than 0. So because n in bn, n start from 1 onwards.
Excuse
so
me,
now,
sir.
yes.
So, sorry to interrupt, but we have another class going on simultaneously right now.
Yeah, I'll finish.
Let's finish it earlier.
Yeah, I'll leave it in just 2 minutes.
Sure,
Sir is
sir.
here.
Sure.
Sir is here only. I'll
Okay.
just take 2 minutes.
Okay, sir. No problem.
So equation 1 becomes, so what is our equation 1? F of x. F of x is x by 2. That is a naught. A naught is I think pi by 2 plus a n is 0 plus summation n from 1 to infinity. Bn is minus 1 by n sine nx. So 2 pi get cancelled, sine nx. So that required Fourier series expansion for the given function in that interval is pi by 2 minus summation n from 1 to infinity, summation n from 1 to infinity. So that is sine nx by n. So this is the required Fourier series expansion. So we have to find this results. Okay. Any doubt will, I mean, those who have any doubt, we can discuss that in the next class. Uh, I just download your attendance. Okay, the one thing I request you to, please make sure your names to be typed like your name and registration number. It has to be visible your registration number also. So otherwise I cannot give attendance those who taken like live.cid some.8. I don't know who are you, and even just Kishu 2059.
Sir, we don't have the authority to change names. Only the IT department has the authority.
No, you try because some of your friends in other section have did. I don't know how they are.